Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Donuts by Malrog, and here are the rules. Normal Sudoku rules apply. Place the digits from 1 to 9 in every row, column, and region without repeats. Digits in cages cannot repeat and sum to the total in the top left corner of the cage, if given. So that would mean these 8 digits add up to 40. These 3 digits add up to 13. These 2 digits add up to 13, etc., etc. So an example here would be if this were 5 and 8, that would satisfy this 13 cage because both of those digits add up to 13. Excuse me. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, first things first, all these donuts, which is very clever, are eight digits, which add up to a certain value. Now, the 40 tells us something about that, right? What it's saying is that this must be the digits. It cannot, every digit except for 1 adds up to 40. Well, the only digits that work that way is 1 through 4 and then 6 through 9, right? Because 6 through 9 add up to 30, 1 through 4 add up to 10. So that adds up to 40 in total. And we know that's the case because digits cannot repeat in cages. So therefore, this must contain a 1. And there cannot be a 5 here, right? So we know one of these 3 is a 1. Similarly, for this donut, we know it's the digits 1 through 3 and then 5 through 9, right? Because 45 minus 41 is 4, and there's only one digit that's not in this donut. Therefore, it has to be 4 that's not in the donut, which means 3 has to be one of these 3 cells. In addition, we know 1 cannot be any of these cells here, so the 1 has to be one of these 3 cells here. Since 1 is one of these 3 cells, that means in box 2, the 1s cannot be here and the 1s cannot be here. So one of these cells has to be a 1. Okay, so similarly with this, you can figure out what digit is missing here. So there, again, 8 digits add up to 42. 45 minus 42 is a 3. So therefore, none of these digits can contain a 3. But the 4 could be trickier here. The 4 could be in this cell. It cannot be any of these cells because those all see the 4 here. But this could be, the 4 cell could be here or one of these 3. We're not sure which. Similarly, with this one, the 5, we know this is specifically the digits 1 and then 3 through 9. So the 5 has to be here somewhere, but it cannot be these 3, and it cannot be here. So it could be here, or it could be any of these 3. We're not sure which. Let's see. So we know this 13 cage cannot include a 1. What can it be? It could be 2, 3, and 8. It could be 2, 4, 7. Or it could be 2, 5, 6. And it could also be 3, 4, and 6, right? We don't know. So 2, and 2 is not in this donut because we know that this is 1 through... Wait, no, 2 could be in this donut. This is the 42 donut, right? 3 is not in this donut. Interesting. 2 cannot be here. So 2 in this cage, this donut, must be one of these 5 cells. 2 also cannot be in this cage. So 2 has to be in this donut still because it's missing a 4. And it has to be one of these cells, right? Well, we have a 2 that's in rows 2 and 3 in box 1, and we have another 2, which must be in rows 2 and 3 in box 3. So where is the 2 going to be in box 2? It has to be one of these cells. So it has to be either here or here. We know also 3 cannot be here in this cage and here in this cage because we have a 3. We know that certain here. Oh, this can't be a 3. And this can't be 1, right? And this can't be 4. My apologies. And this can't be 5. So 3 is one of these two cells in this cage because we need a 1 through 3 and a 5 through 9. And 3 obviously is eliminated by this cell from these parts, so it must be one of these. Therefore, 3 cannot be here. 3 cannot be here. Where is the 3 in this cage, which does require 3? It has to be here. Well, we have a 3 which eliminates all the 3's here and all the 3's here. What about this one? What can this be? Where can the 3 be in box 2? It has to be one of these 3 cells. So now, all of these cells must be 1, 2, or 3, because those are the only places for it. So this has to be a 1, 2, 3 triplet, which means in the rest of the box, it has to be 4 through 9. That doesn't really tell us much, but... Also, we know in this box, 5 cannot be anywhere in this cage, and it can't be here, so where's the 5 in box 1? It has to be here. And similarly, this box cannot contain a 4, and this can't be 4. Where is the 4? It has to be one of these 3 cells. So therefore 4 cannot, in box 1, cannot be here. So the 4 must be one of these 3 cells, because it can't be 4 here because of that 4. Therefore, we know this cannot contain a 4. Well, 4 can also not be in this cell, which means where is the 4 in row 4? It can't be this one because we know we have a 4 here, and that eliminates any possibility for those to have a 4. And this cage cannot ever have a 4, period, because it has 8 digits adding up to 41. And 8 unique digits adding up to 41. So therefore, this can't be 4. Therefore, 4 has to be one of these 2 cells, which means this cage cannot have a 4 anymore in it. So these cannot be 4. Where is the 4 in box 2? It must be one of these 3 cells, which means neither of these 2 cells can be a 4, which makes this the only possibility to be a 4. So this is a 4. One of these 2 cells is a 4. So that eliminates 4 from the rest of the box, so this can't be a 4. And we probably have a similar case for 5s in box 3. So this has to be a 5, right? Because these 2 can't be 5s because of this, and one of these 5s eliminates that from being a 5. So 5 has to be one of these 3 cells. Because of that, where we know there's no 5 here, because this cage cannot contain a 5, this cannot be a 5 because we have a 5 in one of these 3 cells. Where's the 5 in row 4? It must be one of these 2 cells, which means this cannot be a 5. Which means, where's the 5 in box 2? It has to be one of these 3 cells, which eliminates both of these cells from being a 5. Therefore, this is a 5. And we also know this is a 4, 5, 4, 5 pair now, because those are the only places that could be 4 and 5 in that entire row. So this is 4, 5, 4, 5. What do we have here then? So this is 4, 5. That means this cannot be 5. What else do we have? So the 4 is either in this cell or this cell. Okay. If this is 4, that would make this 5, which would make that 4. So this could actually be 5 here then. Let's see. 2 obviously can't be here or any of these. 2 also cannot be here. Oh, where can the 1s be? Because there's a 1 here, there cannot be a 1 here and here. The 1 cannot be here in this cell, so 1 has to be one of these 4 cells. We're not sure which. Similarly with 3, 3 cannot be any of these cells. Therefore, 3 has to be one of these 4 cells, because otherwise this 3 sees that one, this one sees one of these 2. This is 4, 5. So 3 out of 6, 7, and 9 are here. Ah. Okay. Bingo. What digit is missing from this cage? Well, we know none of these can be 2, and these can't be 2 anymore because of this 1, 2, 3 triplet. So therefore we must be missing a 2, because 2 can never be in this cage. Well, what does that mean then? That means it must contain 1 and 3 somewhere in this cell, and the rest are 6, 7, 8, and 9, right? So 1 and 3 have to be in these 3 cells, which means this cannot be 1, and this cannot be 3. So the remaining cells now are 6, 7, 8, and 9. 1 and 3 cannot be here. Therefore, 3 has to be one of these 3 cells, and 1 has to be one of these 3 cells, right? What else do we have? We have 3 digits from 6, 7, or 6, 7, 8, or 9, right? This can never have a 3, right? Because it's 8 digits adding up to 42. That means the remaining digit must be, that's not in the cage, must be a 3. Therefore, 3 can never be here. So therefore, this is a 3. 1 could be any of these 3, though, right? So this is 3, which means these 2 digits add up to 10, which is 13 minus 3. Cannot be 1 because we know the 1 has to be here in this box. It could be 2, so it could be 2 and 8. Or it cannot be 3 and 7 here because we already have a 3. It could be 4 and 6, so this would be 4 and 6 if that's the case. So this is 6 or 8 with this, right? 3 cannot be here, 3 cannot be any of these. Therefore, one of these 2 must be a 3. I'm not sure where. One of these 3 obviously is a 3. This can't be 3. Let's see. This doesn't tell us very much. The 4 has to be one of these 2, right? This cannot have a 2 in it. Therefore, we know there's either a 2 here or this is 2. Well, okay, there's no 3 in any of these, right? This can't be 3 digits with a 3. So it has to be then 1, 4, and 8. So it could be 1, 4. Oh, that wouldn't work because if this were 1, 4, and 8, this would eliminate all possibilities for these 2 cells, right? Because this has to have be 2 and 8 or 4 and 6, and 4 and 8 would eliminate both. Obviously can't be 1, 3, 9 because the 3 can't be in the rest of the box. So 1, 3, 9's out, 1, 4, 8 is out. It could be 1, 5, 7. That is a possibility. And so this would be 1, 5, and 7 if that's the case. Obviously, that's the only case for 1 then. What about 2? Um, 2 could be what? It cannot be 238. It could be 247 if one of these is 2 and 4, right? So if one of these is 2 or 4 and 7, and then we had 2 or 4 here, that could work. And 256 also works if this is 5, and one of these is 2 and 6, and one of these is 2 and 6. This has to be 6, 7, 8, 9, and we have the 3 possible. This is also 6, 7, 8, 9, and we have a 1 possible. So one of these is 2 with 6, 7, 8, 9, and one of these is 2 with 6, 7, 8, 9. And one of these is 2. So this has to be 1 or 2 in this situation, right? This can never be 2. This cannot be 1. So the 5 is one of these two. The 4 is one of those two. This cannot be 1, 3, or 4. So it could be 2, 5, 6, 7, 8, 9. This cannot be 1, 2, 1, 3, or 5. So this could be 2, 4, 6, 7, 8, 9. That doesn't really tell us very much. This has to specifically be 4, 9, 5, 8, or 6, 7, but we're not sure which. Ah, okay. Where are the 4 and 5 in column 5? Can't be any of these. Can't be here. Can't be here. Can't be here because of the 4, 5 here. Can't be here because of the 4, 5 has to be one of these 3 cells. Therefore, the only possibilities would be one of these, which it could be, and this one. So this must be specifically a 4, 5, and this must be one of the 4, 5s. Huh, interesting. Um, hmm. This can't be 3 anymore. One of these 2 is a 3. One of these 2 is a 3. Um, where is the 2? Not sure that helps much. So 3 cannot be here. 3 cannot be here. So 3 has to be one of these 3 cells. 3 also has to be one of these 3 cells. We have 1 with 2 and then 6, 7, 8, or 9. Hmm. Huh. Okay, so whatever. Oh, that's interesting. Whatever non-2 digit is here. So say it was here, right? If this was the non-2 digit, it has to be one of these two, actually. So then it has to be outside, which is 3. Well, it can't be any of these. It must be one of these then, right? And it also must be one of these 3 cells, right? Which means that it would have to be one of these 2 cells if that's the case. Hmm. Ah. How does that work? Right? This would only be that possibility if it were 6, specifically in this case. Otherwise, it would always be that cell, right? And if that were the case, so say this was a 6, right? If this were a 6, and then this would be 6, 6, 6, this, and we tried to make this a 6. Well, what can that 6 be with? It can only be with 2 and 5, right? Well, we know this is a 6, so therefore 4 and 6 is gone. But then this 2 also says that 2 and 8 is not possible, so therefore it's not a possibility. Therefore, whatever cell is not a 2, if this is a 2, or sorry, if this is not a 2, it would obviously have to be one of these 2 cells. It would have to be one of these 3 cells, which means in this cage, it would have to be one of these 3 cells. In addition, because it's not one of these 3 cells, it has to be the remaining cell here. And it can't be this one because of normal Sudoku. And it can't be this one because we eliminated the only possibility of this being this being essentially a whatever this digit was. So it would have to be here if that's the case, right? Um, right. So if that were the case, then this would never be a 5, which would mean this would be a 5. So this would have to be 4, 9, which would mean this would have to be a 4 if that's the case. But if this were essentially the non-2, then similarly, it would have to be one of these 2 cells. It would have to be one of these 3 cells then in box 3 because these would be all eliminated. Therefore, in this cage, it would have to be one of these 3 cells because it has to be in this cage as a 6, 7, 8, or 9. And again, it would have to be one of these 3 cells because it's not here um, in this cage. And that cage requires all the 6, 7, 8s, and 9s. which means that in this cage, it wouldn't be here, and it would have to be here, which would mean this is a 4. And then, therefore, this would have to be 5 and 8. What does that mean? Well, this would be 4 and 6 then in that case. This would be a non-2. If that were the case, then that means this can never be 2, right? If this were 2, the problem is this would be 4, 6. But that would require... Is that... Yeah. This would have to be 4. This would be 5, 8. So this could not be 5. Therefore, this would be 5. And we would not have this whatever digit that was not a 2. So obviously, we tried to make this a 2. This would be 4 and 6. This would have to be a 4, which makes this 5, 8, which means this is a 5. This could not be 1, 5, 7 anymore. It could not be 2, 5, 6. It could not be 2, 4. This, I guess, could be technically 4, 2, and 7. But the problem is, where is this digit then? Say it was a 2, right? If this was a 2, then we go the opposite side. This has to be, this would be 5. This would be 4. This would be 5, 8. So this would be 4. Therefore, this would have to be the other digit. Either way, so if it goes this way, and then... So either it's here, here, and here. And the problem is this digit would have to be here. It obviously would not be here. It would have to be here. And then all 3 of these would be not possible because this one sees this one and it cannot be 4 or 5. Now, if it tried to be here, it cannot be here, obviously. So it would be one of these 3, then one of these 3. But then it can't be either of these digits, and it would see that one. So yeah, 2 does not work there. So 2 has to be one of these 2 cells or one of these 2 cells. Whatever this cell is must be one of these 2 cells. And these 2 cells must be the corresponding ones here, right? I don't know if this tells us anything. If it's here, it would be one of those 2. And obviously it would not be here. Don't know if that tells us anything. So either this matches... It's this matching this one, or this matches this one. We're not sure which. Either way, though, how does that work? If this matches this one, this obviously has to be a 2. which means this has to be a 2 something, right? 247 or 256. Obviously can't be 238, and those are the only possibilities. So 247, 256. So if this is a 2, sorry, if this is not a 2, this was a matching one. Obviously, the last one would have to be one of those 3 cells. This would have to be 4 and 6. So this would be 2, which means 2 cannot be here. This would not be 4, so this would have to be a 4, which means this is 5, 8, so this can't be 5, therefore this is 5. Oh, that's interesting. Okay, so what are the possibilities? Again, the green could be the matching pair. So these two are essentially the same, in which case this would be 4. This would have to be 5, 8. So this couldn't be 5, and therefore this couldn't be 5. So this could not be 1, 5, 7. This would specifically have to be 4 and 6. So this would have to be 4, and this would be 2 and 7. Right? Huh, interesting. So that's interesting. Then this cannot be 6, right? Because if that were 6, then obviously that would be 6, but then this would have to be 4 and 6. So this doesn't work as a 6. Actually, I don't think it works as a 7 either, right? Because this is 2 and 7. Whatever this digit is, cannot be any of these, so it must be one of these two, and it must be one of those 3, so then it has to be here. So this cannot be 7 either. So it has to be 8 or 9 to be one of these cells, right? Because this would be 2, 7 specifically. So then the 7 would have to be here, which means the 7 would have to be here. Obviously, the 7 would be here. Then this would be 7, then this would be 7. That works. Let's see. So that works for there. What about this one, right? If this is the same as that, then this cannot be 5, so therefore this would be 5. This would be 4, 9, which means this can't be 4. So this would be 4. This would have to be 2 and 8. So this can no longer be 8, which means 8's one of these 3, which means 8's one of these 3. So this couldn't be 8. So this specifically can't be 8. This would not be 2 here, or 8. 8 is one of these 3, 8 is one of these 3. 4 would be here. It could be 1, 5, 7. Oh, wait, no, it couldn't, right? Aha, okay. That's one thing we've learned. So, we tried making these two essentially the same digit, and we showed that this has to be 247 in that case, right? Because if these are the same digit, this has to be a 4, because that's the only possibility for 4 in that cage then, remaining. Therefore, this cannot be 4, 9. It has to be 5, 8, which means this can't be 5. Therefore, this is a 5, so it can't be 1, 5, 7, and it can't be 2, 5, 6. It has to be 2, 4, 7 if that's the case. And then we tried, oh, that's interesting. So we tried this one being the corresponding one. Therefore, this has to be a 5, which makes this 4, 9. So this can't be 4. So this is 4. This has to be 2 and 8. This is no longer 5. Therefore, this would have to be 5. Wait. Yeah. And this can't be 2 anymore. This is obviously not a 2, but this could be 2 or 4. But the problem is 4 would be here, and this can't be 2, actually. Okay, yeah, the problem here is, so if this is the same as this one, okay, let's do the 2 scenarios. This digit is the same as this one. Therefore, this can't be 4, so this must be a 4, right? This is 4, which means this is 5, 8, which means this can't be 5. Therefore, this is 5. So this has to be, and this has to be 4 and 6 specifically. So 4 cannot be here. This cannot be 5, so that eliminates 1, 5, 7, or 2, 4, 6. So therefore, this has to be 4, and this has to be specifically 2, 7. Because that's the only one possible now. So this would not be 1 with 5 or 7. Because of that, we know that in that case it would be 2, 4, 7 here, right? Now, what happens if this is that digit instead of that one? So this cannot be 5. This has to be 5 then, which makes this a 5. This can't be, let's do that one. If this is not a 5, this is a 5, which makes this a 5. This can't be 5, 8, so this must be 4, 9. So that 4 can't be here. This must be a 4. This can't be 4, and this can't be 6. Well, we know this digit is equal to that. Well, where is the 4, right? 4 cannot be here. 4 cannot be with 5 to add up to 13 because it would have to be 4, 4, and 5. Therefore, this would have to be a 4, and therefore this would have to be 2 and 6, which would force this to be 2 and that to be 6, if that's the case. Either way, this can never be 1, 5, 7. The 2 then always has to be in this 13 cage, right? So this cannot be 1. This cannot be 1. 1 has to be one of those 2. In addition, we know 2 is always here, and this is either 2 and 6. Sorry, 2 or 4. If this is 4, this would be 2, 7. If this is 2, it specifically has to be 5 and 6. So this can't be 4 either way. This cannot contain a 2 because we know that the 2 always has to be in this 13 cage. This is either a 2, 7 or it's 5 and 6. So this has to contain a 2 or 6. This must contain a 2 or 6. So therefore, we have both of these sets of 4 must contain either a 2 or a 6, which means a 2 and a 6 cannot be in the rest of the row. So this can't be 2 or 6. These can't be 6, and this can't be 6 here. Now this is 6 or 8, and this is 6 or 7. So we don't really have any information about that. So either way, one of these is a 2. So this has to be 4, 8, or 9. Because it has to match this cell, or it has to be a 4. This cell, I don't think this can ever be a 1. If this were a 1, it doesn't match this cell, and then that has to be a 5. So therefore this must be 2, but then these must match, and therefore this would have to be 4, and this would have to be a 5, and that would eliminate all possibilities for this 13 cage. So this can never be 1. This has to always be a 1 then, which means this can't be 1. There's no 1 in the rest of this box. So this can't be 1, and this can't be 1. Therefore, 1 has to be one of these cells. We're not sure which. This has to be either a 5 or it's a 6, 7, or 9. Right? Because it cannot be 8 because of what we determined here. This could be a 5. It could be a 2. It cannot be 1, 3, or 4. It could be 6, 7, 8, and 9, right? If this were 2, this would have to be an 8 or 9. But that can be 2. Where's the 2 in box 4? It would have to be here, so this would be 2, 8. But that would force this to be a 4. And therefore, this 8 and 9 would not match this one. This wouldn't be a 4, but that couldn't be a 4. This would be a 2, which would be not matching here. So this would be 2. And that would be 5, 6. But then this would be 5, and that would... Well, okay. This digit would not be able to... I guess it could be... No, again, because this digit has to be one of these digits here, which eliminates that possibility. Yeah. So that would break. So this can never be 2. Because either that's 2 or one of these two is a 2. If one of these is a 2, this would have to be 4, which means this could not be the same as that one, and therefore would have to be a 2. Otherwise... Okay, so where's the 5 in box 4? It cannot be any of these cells. Can't be any of these because of the cage, so it must be one of these two. Which means this can never be 5. 4 could be either here or here, so that doesn't... We don't know anything about that. Oh, interesting. If this were 4... that would eliminate 4 from being any of these cells here. And this could not be 4. So if this were 4, that eliminates all of these cells from being a 4. This can't be a 4 because of that 4. And we've already determined this can never be 4. Therefore, this can never be 4 here, which means this must be a 4. Which means this has to be a 2-8 pair to add up to 10. 8 can no longer be any of these. This can't be a 4, so this must be a 2. This can't be 4. This can't be this digit, so therefore it has to be a 2. So we know this is not correct. This has to be the same digit here. So we know this one must be the same as this. So this is not a 2. This is not a 2, obviously. This isn't 2. This is not a 5 because it has to be the same digit. Therefore, this is a 5, and that must be 6. Therefore, this must be a 5. This can't be 2, 6, 7, 8, or 9. because we have a 6, 7, 8, 9 quad in row 6, which eliminates 6, 7, 8, and 9. Therefore, this must be 5, which means this can't be 5, cannot be 8 either. So this can't be 5 or 8. This can't be 8, cannot be 8. This is the 5. This cannot be 5 or 8. It has to be 4, 9. This can't be 5, so this is a 4. Not 5, it's a 4. This is 4, so this can't be 4. So this is a 5. This can't be a 4, so this must be a 5. So neither of these can be 4 or 5. It has to be the same as the orange. So this is the orange, this is the orange, this is the orange. This has to be a 4, because that's the only remaining cell there. Therefore, one of these two is the orange. We're not sure which. And one of these three is the orange. We're not sure which. We have 5 here and 5 here. One of these must be a 5. Because one of these must be a 5, this can never be 3 anymore, right? Because if it's 3 and 5 added together, well, what digit can you add to that to add up to 13? It would have to be another 5, which breaks Sudoku rules. So this cannot be 3. 5 can't be here again. 5 can't be here or here. 5 has to be in the cage. So therefore, this is a 3, which means this can't be 3. This has to be a 3. And this can't be 2 because of the 2 already there. So 5 is in one of these cells, which means the other two cells must add up to 8, right? Because 13 minus 5 is 8. And we have 2 cells remaining, so it's either 1, 7, or it's 1, 7, or it's 2, 6 with the 5. So this can't be 5, obviously. This is 1, 7, or it's 2, 6. This can't be 1, though. 1 has to be one of these 3. 3 is obviously here. 3 is one of these 2. We're not sure which. Where is the 4 in this cage, which does have to have a 4? It must be one of these 2 cells, because it can't be here, can't be any of these. This can't be 9. This can't be 9. Oops. This can't be 9. This can't be 9. This can't be 9. This is 2, 5, and 6, which means 6 cannot be here. And this can't be 6, and this can't be 6, which means that can't be 6. Therefore, it's a 7 or 9 here. The orange has to be one of those. Where is the 4 in box 6? It has to be here. So this is a 4, which means this can't be 4. Which means this can't be 4. Where's the 4 in this cage? It has to be here. So this is a 4, which means this can't be 4. Therefore, this is a 4. So this can't be 4 anymore, so this is 9, which makes that a 4. The 9 cannot be any of these cells. Cannot be any of these cells. What's remaining here? So this cannot be 2. This could be 2, I guess. This could be 1 and 1. This could be 1, so this could be 1. This can't be 1. We know the 1 cannot be here. Oh, it could be 1. This has to be 1, 3, 6, 7, 8. This is 1, 3, 7, 8, 9, and these are 1, 3, 7, 8, 9. Oh, this can't be 3. There's no 4 here. So it could be 1, 3, 9. That's fine. This can't be 3. So it would be 3. So this can never be 9. Because if this is 9, this would have to be with 1 and 3. And that's not possible for these cells because that's 3. So this could be 1, 9, 1, 9, 3. cannot be 148. It could be, it cannot be 157 because there's no 157. It could be 238, in which case this is 2, that's 3, this is 8. What else can it be? Cannot be 247, cannot be 256, and cannot be 346. So these are the only possibilities. Therefore, we know this is a 3. So this can never be 3. This can never be 3. Whereas the 3 in this box, it has to be here specifically. So this is a 3. One of these is 8, which we knew. One of these is 8, which means this can't be 8. So it's 1, 3, 7, or 9 here. This is 3 with 1 and 9, or it's 2 and 8, so this cannot be 7. This can't be 9, because if this is 9, where's the 1 in this box? It can't be here because of this 1. This can't be 3. This can't be 3, therefore this must be a 3 here, which means this can't be 3. So again, if this were 9, where's the 1 in box 9? Cannot be here because of this one sees it. Cannot be here because of the cage, and this can't be 1 or 9 anymore, so this can't be here. So 1 would not be allowed to be in anywhere in the box, therefore this can't be 9. This is 1, 7, or 8. This cannot contain a 2. So either way then, we know this, neither of these can be 2 because of this has to be 6, 7, 8, and 9, right? So the 2 in box 9 has to be one of these two cells, which means this cannot be 2. So if this were 2, 5, and 6, this could not be 6, right? Because the 2 would have to be here. This can't be 9. We have a 7, 8, 9 triplet in this cage, which means that in the rest of the cage, you cannot have 7, 8, or 9. Therefore, we know this is a 1, which means this cannot be 1, which means this cannot be 1. Where's the only other place for the 1? It has to be here. So this is a 1, which makes this a 9 to add up to 13. This must be a 2. This can no longer be 9. This can't be 9. This has to be remaining 2 and 6. Right? So therefore, this is 7, 8, and 9. The orange has to be either here or here. We're not sure which one. This cannot be 1 either. Therefore, this is 5 and 5 with 6 or 7, and this has to be 1 or 2. Okay. This cannot be 5, well, it never could be 5. This can never be 8 here. So one of these two is an 8. And the last one is a 7 or 9, right? Now here we know there's a 1 and a 6. This is 6 or 8. This is a 3, so this can't be 3, and this can't be 3. This can't be 2. Where is the 2 in column 6? It has to be here, which makes that a 2. So this can't be 2. Where's the 1 in column 6? Can't be here. Can't be any of these. Therefore, it must be here. So this is a 1, which means these can't be 1. So one of these is a 3. This has to be 6, 7, or 8. This has to be 1, 2, 6, 7, 8. And obviously this can't be 1. 2 could be any of these. 1 could be any of these. There is no 3. I think all the 3s are already taken. No, they're not. Okay. This is the opposite 7, 9. It's not the orange one, so we'll go make it a green one, I guess. Well, this one can't be the orange 7 or 9. It cannot be the green 7 or 9. Therefore, this can't be 7 or 9, period. So this must be an 8, which makes this not an 8, and this is the green 7 or 9. The green 7 or 9 has to be one of these three. It must be one of those three. It must be one of those two. One of these two is the green 7 or 9. This is 8, so this can't be 8. This can't be 2 either. So this has to be 6, 7, or 9. What's remaining? This can't be 9. So we know the 9 has to be one of those two, but we're not sure which. The green 7 or 9 could be any of these three. This has to be 6, 7, or 8. And this is... cannot be 3, 4, 5, or 9. So it could be 1, 2, 6, 7, or 8 here. We know this can't be 2. And none of these can be 2. Therefore, where is the 2 in column 4? It must be one of these two cells, which means the 2 cannot be in the rest of the cage. So this cannot be a 2. Therefore, we know it cannot be 2, cannot be here because it can't be in the rest of the cage. It can't be here because of this cell. It must be one of these two cells, which means this can't be 2. Therefore, this is an 8, which makes this a 2. Now we know 8 cannot be here, and 8 cannot be here, and 8 can't be here. So therefore, one of these two cells is an 8, which means this cannot be 8. None of the rest of the cells can be an 8. What else do we have here? One of these two cells is a 2. One of these two cells is an 8. Either this is a 9 or that's a 9. One of these two cells is a 6, so the rest of the cage cannot contain a 6 because of how this works, right? Therefore, this can't be a 6. Therefore, one of these two is a 6. Okay. One of these two cells is an 8. One of these three cells is an 8. In rows 7 and 8. This is row 7 and 8 also for box 7 and 9. Therefore, the rest of box 8 can only have an 8 in one of these two cells then. So this can't be an 8. We're still not certain what this is though. This is the orange. Okay. Huh. This must be the green 7 or 9. This is the green 7 or 9. The green 7 or 9 could be any of these, unfortunately. Oh, this can't be 2, so this can't be 6. Which, sorry, this can't be 2, so this is 6, which means this is 2. This can't be 6. So where is the 6 in box 9? It must be here. So this is a 6. These can no longer be 6. This can't be a 6. This is what? 1, 2, 7, 8, 9. And obviously this can't be 8. This can't be 2. This can't be 1. This is 5 through 9. No 8. 5, 6, 7, 9. No 8. We know that 8 is one of those two. That doesn't really tell us much. Hmm. Huh. Um. Huh. Hmm. Ah. One of these two cells must contain 9 here for this cage. So this cannot be 9 anymore. Which means this can't be 9, right? Because we know one of these two cells has to be a 9. So that eliminates 9 from the rest of the row. So this can't be 9. We now have a 1, 2, 6, 7 triple in this cage, which means this cannot contain 1, 2, 6, or 7 in the rest of the cage. Therefore, this can't be 6 or 7. This must be an 8. This can't be 7 or 8 now, which must mean that must be a 9. So this can't be 9. We now have a 1, 2, 7 triplet in row 7, which eliminates 1, 2, and 7 from the rest of the row. Therefore, this must be an 8, and it cannot be the orange then, because 8 is never the orange. So therefore, the orange must be a 9. So this must be 9, this must be 9, and this must be 9. So therefore, this is a 7, this is a 7. None of these can be 7. These can't be 9. So this can no longer be 9 here, so this must be a 6, which means this can't be 6. This cannot be the green, because neither of those are 7. Therefore, this must be the green, and it must be 7, which makes this a 5. 1, 5, and 7 add up to 13, so therefore this must be a 2. This must be a 6. This can't be 2 anymore, so this must be 2. Where's the 1 in this cage? It has to be here, and this has to be a 7, because the 6 is already eliminated from that cage. This can't be 1 anymore, so this is 7. This can't be 1 or 6, so this is 9, and therefore the orange. This is the orange, too. So this can't be orange anymore because of the 9 is the orange. Therefore, this is a 9. Neither of these can be orange. Oops, this is supposed to be 5, 6, or 9. We eliminate the not 7s instead of the 9s. But neither of these can be 9. Therefore, this is the orange, and it is the 9. 9, not 6. This can't be 9. This can't be 9. This can't be 8, so this must be the 7, which makes that the green. Which means this can't be green. This has to be green, which means that can't be green. So all the greens are 7. This can't be 1 anymore, so this must be 3, which makes this a 1. These can't be 9 anymore, so it's 6, 7, or 8. This can't be 5, so that makes this 6. We're doing now just Sudoku, so this is 5. This can't be 6 or 9, so this is 1. This can't be 7, so this is 8. This can't be 7, so this is 8. This has to be a 3, because that's the only place for it. This can't be 7, and this can't be 7. These can't be 7. This can't be 7 or 9, so this must be 8, which makes this a 6. This 8 makes that a 6. This can't be 6 or 8, so this is 7. This can't be 6 or 7, so this is 8, which makes that a 6, and therefore this is an 8. And that's how you solve it. Pretty cool use of these donut cages. Yeah. I like particularly figuring out that you had a 2 or you had some other digit here, and the other digit had to be in one of these two spots, which eliminated the 4 and the 5, and then you had the 4. Where could the 4 be in this cage? And the only possibility was would remove this from being able to be the 4. Pretty cool puzzle. And I hope you enjoyed solving this puzzle, and I'll see you next time on Frank Puzzles. Take care.